Very good morning to students. This is Ramamani. Whatever my paper, object oriented software engineering. This is the first chapter, introduction. Here, the first topic of the first chapter, nature of software. Here, whatever the nature of the software, untrained people can hack something together, and the software is easy to modify. Software does not wear out. Untrained people can hack something together. Quality problems are hard to notice. Software is easy to modify. People make changes without fully understanding it. Software does not wear out. It deteriorates by having its design changed erroneously or in ways that were not anticipated, thus making it complex. So the main features of nature of software is untrained people can hack. Software is easy to modify. Software does not wear out. And conclusion, much software has poor design and is getting worse. Demand for software is high and rising. We are in a perpetual software crisis. We have to learn to engineer software. This is the conclusion. So software has poor design and the demand for software is high. We are in a perpetual software crisis. We have to learn to engineer software. And next, after the nature of software, we have to know whatever the types of software. Three types: custom, generic, and embedded. Custom is for a specific customer. The software application is designed for the requirement of a specific customer is called as custom software. Generic software sold on open market, often called COTS, commercial of the shelf components, shrink wrapped operating systems or packages. What we generally used in our computer systems is called as generic. Embedded system built into hardware, hard to change. This is the built-in software we can use in the remote car remotes, and next in the remote ovens and the remote CC cams. Here, whatever it may be, embedded software is a built-in software into hardware. And difference among custom, generic, and embedded software. Here, number of copies in use. Generally, the embedded software copies are maximum utilized. Total processing power devoted to running this type of software. In this, generic is high. Total processing power devoted to running this type of software. The power consumption is high for generic software and medium for embedded. And worldwide annual development effort. Custom software has worldwide annual development effort, that is the high. And next, seventh slide. Okay, types of software. Real time software. Here, example, control and monitoring systems must react immediately. Safety often a concern. Real time software. Example, control and monitoring systems. Data processing software used to run business. Accuracy and security of data are key. See our data processing software used to run business. Eighth slide. What is software engineering? We are going to do exercise and understand the definition of the software engineering. The process of solving customers' problems by the systematic development and evolution of large, high quality software systems within cost, time, and other constraints. So, solving customers' problem, that's the definition. By the specific development, systematic development, and evolution of large, high quality software systems within cost, time, and other constraints. So, solving customers' problem, what it is, we're going to discuss in detailed manner. This is the goal of software engineering. Sometimes the solution is to buy, not build. Adding unnecessary features does not help solve the problem. Software engineers must communicate effectively to identify and understand the problem. So, solving customers' problem is the goal of software engineering. So sometimes the solution is not to buy. Adding unnecessary features does not help solve the problem. Software engineers must communicate effectively to identify and understand the problem. What is software engineering? Continuing of the customer's problem solving. Next, systematic development and evaluation. An engineering process involves applying well understood techniques in a organized and disciplined way. We want to solve the problem, customer's problem, in a systematic approach, that is applying well understood techniques. We are using techniques in making the software in an organized and disciplined way. Many well accepted practices have been formally standardized by the IEEE or ISO. Standard bodies are recognized the techniques. Most development work is evaluation. Large high quality software systems. Software engineering techniques are needed because large systems cannot be completely understood by one person. So teamwork and coordination required. We know that large systems, complex systems, huge amount of data we have to deal. So single person is not enough. A teamwork and coordination are required. Key challenge: dividing up the work and ensuring that the parts of the system work properly together. So dividing up the work and ensuring that the parts of the system work properly together. The end product that is produced must be of sufficient quality. What is software engineering? Continuation, that is the cost, time, and other constraints. Here, finite resources we have to use. The benefit must outweigh the cost. So, cost benefit analysis, whatever the investment of cost will be compared with the outcome or service of the software. It must be high than the investment of the cost. Others are competing to do job cheaper and faster. Inaccurate estimates of cost and time have caused many project failures. Others are competing to do the same job cheaper and faster. We have to face inaccurate estimates of cost and time have caused many project failures. Next, software engineering and the engineering profession. The term software engineering was coined in 1968. People began to realize that the principles of engineering should be applied to software development. The principles of engineering principles applied to software. Engineering is a licensed profession. In order to protect the public, engineers design artifacts that are products following well accepted practices, which involves the application of science, mathematics, and economics. Ethical practices is also a key tenet of the profession. Stakeholders in the software. The next, nature of the software and the definition of the software. After that, stakeholders in software engineering: users, customers, software developers, and development managers. The four roles can be fulfilled by the same person, maybe requirement based on those who use the software system called as users. So those who pay money for the software, that's the customers. Software developers and development managers are especially focused on the development of the software. And software quality factors, what we have, that's the usability, efficiency, reliability, maintainability, reusability. So users can learn it and fast and get their job done easily. Easy to use is the usability. Efficiency, it does not waste resources such as CPU time and memory maximum utilization, and CPU time also. And reliability, it does what it is required to do without failing. So fail without it does. So complete assurance of the doing the task. Maintainability, it can be easily changed. Reusability, its parts can be used in other projects, so reprogramming is not needed. That is the advantage of the concept of reuse. And this is the software quality. What we have learned until now, we represented in the quality software in the four roles: customer, user, developer, development manager. User, easy to learn, efficient to use, helps get work done. And customer solves the problem at an acceptable cost in terms of money paid and resources used. Developer and development manager designing their focus is to design easy to maintain and easy to reuse its parts. But development manager focuses on the sells more and pleases customers while costing less to develop and maintenance. And next 15th slide, software quality. The different qualities can conflict. Increasing efficiency can reduce maintainability or reusability. Increasing usability can reduce efficiency. Here comparison: increasing efficiency reduce maintainability, increasing usability can reduce efficiency. Setting objectives for quality is a key engineering activity. You then design to meet the objectives. Avoids over engineering which wastes money. Optimizing is also sometimes necessary. Obtain the highest possible reliability using a fixed budget. So, software quality, different qualities can conflict: efficiency and maintainability. Increasing usability, reduce efficiency. Usability versus efficiency. Setting objectives for quality is a key engineering activity. You then design to meet the objectives. Optimizing is also sometimes necessary. Example: obtain the highest possible reliability using a fixed budget. Next, the quality, internal quality criteria. This characterizes aspects of the design of the software have an effect on the external quality attributes, the amount of commenting of the code, the complexity of the code. Here, internal quality criteria characterize aspects of the design of the software have an effect on the external quality attributes, the amount of commenting of the code, the complexity of the code. Here, short term versus long term quality. Short term: does the software meet the customer's immediate needs? Is it sufficiently efficient for the volume of data we have today? Is it sufficiently efficient for the volume of today we have? So volume may be increased for tomorrow. So is it sufficiently efficient or not? Long term maintainability, customers' future needs also we focus. Software engineering projects. Most projects are evolutionary or maintenance projects involving work on legacy systems. Legacy is the beginning in the past and continuing present also, and may go to the futures, the continuation work of the development. Two types of projects: evolutionary or maintenance project. After completion, we have to maintain such type of project. Maintenance projects: evolutionary, we are amendments or we are adding changes to the project. Corrective projects: fixing defects. Adaptive projects: changing the system in response to changes in operating system, database, rules and regulations. Enhancement projects: adding new features for the users. Re-engineering or perfective projects: changing the system internally so it is more maintainable. So the classification: corrective, adaptive, enhancement and re-engineering or perfective projects. Corrective projects: fixing defects only. Adaptive: changing the system in response to changes in operating system, database, rules and regulations. Enhancement projects: adding new features for users. Re-engineering or perfective projects: changing the system internally so it's more maintainable. And software engineering projects: greenfield projects, new development, the minority of projects. Greenfield projects, new development it requires, and minority of projects. Your software engineering projects that involve building on a framework or a set of existing components. So frameworks we use in building a software. Projects that involve building on a framework or set of existing components. The framework is an application that is missing some important details. So specific rules of this organization. Such projects involve plugging together components that are already developed, provide significant functionality, benefit from reusing a reliable software, provide much of the same freedom to innovate found in greenfield development. The first project started, the type is the greenfield, is the new development, whereas in case of framework dependent applications, they miss some important components. They may be plugged together when we are developing. Activities common to software projects. If we want to develop any software, we have to divide the entire process into set of activities. The activities are listed below. That's the domain analysis, defining the problem, requirements gathering, requirements analysis, requirement specification, domain of analysis, where we are doing the application, where we for which we are developing the application, that's the domain, and defining the problem, and after that whatever the features we want to include in our software development system, we have to first of all collected, that is the obtaining input from as many as resources possible. And requirements analysis, so organizing the information, requirement specification, writing a detailed instruction about how the software should behave. The requirement specification is slightly nearer to the top the technical code and the technical written. And deciding how the requirements should be implemented using the available technology includes soft system engineering, deciding what should be in hardware and what in software. Systems engineering, it involves the both the hardware and software specification, software architecture, deciding the system in subsystems or modules, and deciding how the subsystems will interact, detailed design of the internals of the subsystem, user interface design of database, these are included in the design. And modeling, creating representations of the domain or the software representations using use case model, that is the use case diagrams, and structural model, that is the class diagram, and dynamic and behavioral modeling, that is the representation of sequence and state chart, state diagrams and activity diagrams. And then after programming, then after code writing and quality assurance. After writing the code, we are checking with the reviews and inspections, and testing is the part of the quality assurance. Deployment, we are deploying the software whether it is smoothly working or not, managing the process. These are the steps common to software projects. 8 themes of the book: understanding the customer and the user, basing development on solid principles and reusable technology, object orientation, visual modeling using UML, evaluation of alternatives, iterative development, communicating effectively using documentation, risk management in all software engineering activities. The 8 themes of the book, generally not only in this book, generally we have 8 themes. Understanding the customer and the user, who uses and who pays for the development of the software. We have to understand them first. Basing development on solid principles and reusable technology. Object orientation, the representation of the classes and objects of the domain. Visual modeling using UML notations, evaluation of alternatives, iterative development, and communicating effectively using documentation, and risk management in all software engineering activities. Difficulties and risks in software engineering. So complexity and a large number of details, complexity, uncertainty about technology, uncertainty about requirements, uncertainty about software engineering skills. Why? Because these are changing factors. The system, how much of complexity it has, it depends on the volume of the system, that is a large. And uncertainty of the technology, today's technology may be changed or have less priority of tomorrow. Uncertainty about requirements also we can add in some days. So uncertainty about requirements, uncertainty about system or software engineering skills, constant change, deterioration of software design. So next, political risks. And by this I conclude this class, and thank you students.